Good morning. We're going to start day 9 on polynomial and rational inequalities. We're actually going to spend a couple days on this. I might end up having to break this video into 2 videos because it's pretty lengthy. We'll start with the polynomial inequalities for part 1, and then part 2 will go to the rational inequalities. All right, so let's get started here. We have at the top of your notes the steps, 8 steps to working with polynomial inequalities. Instead of just reading through these 8 steps right now, I'll talk you through an example. So let's just go right to this example. 1. So step 1 says to relate your inequality to 0. Step 1's already done here. This is what it means to relate to 0. It means 0 is on one side. All right, so step 1 is done. Step 2 says you want to create a related equation. Okay, so all that means is we're going to, instead of using this inequality symbol, use an equal sign. So x squared minus 7x plus 10 equals 0. We call this a related equation. I abbreviate it as RE. And we're going to use this equation to help us find what we call our critical values. So step 3 says to factor your related equation. Go here to step 3. And when we factor that, we get x minus 5 times x minus 2 equals 0. Step 4 says we are going to set each of these linear factors equal to 0 and solve. What we're solving for, again, is called our critical values. So here we have a critical value at x equals 5, and here at x equals 2. Okay, so we just completed up to step 4. So this is step 4. Step 5 says we're going to put these critical values on a number line. All right, so let's put a number line down here and put in our critical values, 2 and 5. And now we're going to go to our inequality symbol here, back in the first inequality, and determine whether at those critical values if our circle will be open or closed. All right, so since it's less than or equal to, we have a closed circle on 2 and a closed circle on 5. Okay, so that brings me up to step 6. So this is step 5 and 6. So now in step 7, we are finding points that will satisfy this inequality. We're looking for our solution set to this inequality. There are a couple ways to determine that. One is we have 3 regions here. We have region 1, region 2, and region 3. One idea is to pick a number from each region, substitute it back into the original inequality, and see which number proves true when you plug it back in. If the number proves true for the inequality, then that's the region you would shade, and that would be part of your solution set for the inequality. Okay. In my opinion, maybe a little bit more work than the second idea that I'm about to share with you. The second idea is to consider the signs, positive and negative. Okay. So if we go back up here, we are looking for values that are less than or equal to 0. Okay. So over here has to be result in a number that is less than or equal to 0. That would mean a negative number, right? So this symbol tells us that we're looking for negatives, right? So let's take our factors and write them down here, x minus 5 and x minus 2. So we take our factors here. We pick a number from each region, all right, whatever you want. I'm going to pick 0 here. I'm going to pick 3 here, and I'm going to pick 10 here, whatever. Pick just numbers in that region. Plug those numbers that you pick into these factors. 0 minus 5 would give us a negative. 0 minus 2 would give us a negative. And remember, we're multiplying these. What's a negative times a negative? A positive. Remember, we're looking for negatives, not positives. So I know right now that this is not going to be a region that I shade. It's not part of my solution set. Let's go to the second region. It picks the number 3, plug it in. 3 minus 5 is negative. 3 minus 2 is positive, and a positive times a negative is a negative. And that's what I want. So I know I'm going to shade between those critical values. Just to really hammer home the point, let's try 10. 10 minus 5 is a positive. 10 minus 2 is a positive. I don't care about what the numbers are, just care about the signs. Positive times a positive is a positive. And again, we're not looking for positives, we're looking for negatives. And so that is step 7. And step 8 is to write your solution set in set builder or interval notation. So I'm going to write this as x such that x is greater than or equal to 2, and less than or equal to 5. Or interval notation would be square brackets, 2, comma, 5. Square brackets because 2 and 5 are included in our solution set. All right, so those are the 8 steps to working with polynomial inequalities. Let's go to the next one here. And at this point, you should pause and practice, then hit play and see how you do. Step 1 is not done in this example. So we need to relate this inequality to 0. It means we're going to subtract 4, and we have x squared minus 4 is greater than 0. So that's step 1. Step 2, we're going to write a related equation. So my related equation is x squared minus 4 equals 0. Okay? Step 3, factor. X plus 2, x minus 2 equals 0. Step 4, factor those linear, or set each of those linear factors equal to 0 and solve for our critical values. Okay? So we have critical values at -2 and 2. Now what we're going to do with those critical values is place them on a number line. Okay? So we have -2 here, we have 2 here, which divides our number line into 3 regions. Okay? Now what we're going to do is test a point in each of those regions. I'm going to use the sign method, positive and negative. Go back up here. I'm looking for values that will make this a number greater than 0. Numbers that are greater than 0 must be positive. So I'm looking for positive. All right, so I'm going to pick a number over here, -10, a number in between, 0, and a number to the right over here, 10. I'm going to bring down my factors. Okay, my factors are x plus 2, x minus 2, and I'm going to plug in each of those numbers. I don't care about what it is, I care about the sign. So when I do a -10 plus 2, I get a negative. When I do a -10 minus 2, I get a negative. And a negative times a negative is a positive, right? And that's what I want. Let's plug in 0. 0 plus 2 is positive. 0 minus 2 is negative. And a positive times a negative is a negative. Let's go over here to positive 10. 10 plus 2 is positive. 10 minus 2 is positive. Positive times a positive, positive. So in this example, we have 2 regions that we're going to shade. I skipped part of my step here in putting open or closed circles on my critical values. When we have a greater than or less than, we have open circles. So open circles there. And we're going to shade here and shade here. All right. How do we write this? All right, so that's step 6 and 7. Step 8, let's write our answer. We have x such that, in this case, we have x is going to be less than -2, or in this case, x is greater than 2. If we want to use interval notation, it looks like this: -infinity to -2, union, and union with 2 to infinity. So either one, step builder or interval. Okay. Alrighty. Now we have this next one. Again, pause, try it out, and then hit play. Once you hit play, I'm going to have the answer just already up to save us some time. Okay? All right. So we have here step 1, relate our inequality to 0. Step 2, write our related equation and factor it. Set each factor equal to 0 and find our critical values. So this is step 3 and 4. Step 5, put those critical values on a number line. Okay, so -2 and 6. Go back up here to determine open or closed circles, and we have open circles. Okay, that's step 6. Step 7, test those points. All right, we tested -10, 0, and 10 again. All right, plug them in to our factors and determine the signs. We are looking for negatives, right? We're looking for values that we can plug in here that will result in a negative because we have less than 0. All right, so when we plug in -10, 0, and 10, this region is the only region that produces a product that's negative. That's what we're looking for. So we shade there. This is how you would write it in set builder if you want to write it in interval parentheses because the -2 and 6 are not included. All right, so that's step 8 is to write your answer. Okay, I'm going to pause and we have one more to end with. And then I'm going to just create another video for the rational inequalities, so not to overload you. Okay, this one doesn't have the key handy, so I'm going to work through it with you. So first thing I'm going to do is relate to 0. The second step is to write a related equation. I put RE there to indicate that's what I just did, wrote a related equation. Here we have 4 terms, so we're going to factor by grouping. Okay, and so we have x squared minus 9 times x minus 1 equals 0. We can factor this one further. And then we are going to, after we factor, set each of our linear factors equal to 0 to find critical values. So we have a critical value at 3, -3, and 1. We have 3 critical values, okay? We're going to take those critical values and put them on a number line. All right, make sure we put them in order here. So -3, 1, and 3. Go back here. That tells us open or closed. We have closed, 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 closed. All right, now we have 1, 2, 3, 4 regions. All right, so let's test. -10. Let's pick here 0, 2, and +10. Bring over your factors. Okay, x minus 3, x plus 3, and x minus 1. We are looking for what? Based off this. X values that we plug in here that will result in a what? Positive or negative? A positive. Very good. We're looking for positive products because it's greater than or equal to 0. All right, let's plug in -10. -10 minus 3, that's a negative. negative, negative. What's a negative times a negative times a negative? It's going to be negative. So if you have an odd number of negative factors, your product's going to be negative. Let's plug in 0. Get a negative, a positive, and a negative. So even number of negative factors gives us a positive product. Let's go with 2. We have a negative, a positive, and a positive. So that's negative. I know, that's a little crazy. All right, last but not least, 2 minus 3 is negative. I'm just making sure because I feel like I'm going a little fast. 10 minus 3 is a positive, and a positive is a positive. Okay, so we are looking for those positives. So we want this and this. Okay, so we have square brackets here, -3 to 1 in union with 3 to infinity. All right. Okay, I'm going to stop here and then I will create a new video on the rational inequalities.